Hi everyone, you are watching the Solving Quadratics Pick the Best Method Notes video. In this video, we are not actually going to be solving anything, but instead we are going to become these great math students who can look at a quadratic equation and the directions that they give us, and we are going to decide what method will be best. Because when you're solving quadratic equations, or any equations actually, it is always best to pick the most efficient method to help save you some time. So we are just going to review some of those methods before we dive in, but you probably remember we started off the unit with factoring. And the directions usually just say solve. There isn't anything fancy after it, like write in simplest radical form or anything about a decimal. Square roots, we use square roots when there isn't an x term, or really when it has that special form where it looks something like this, like the chunk squared equaling a number. Do we remember that, where it was like x plus or minus a number, all squared equaling a number. The quadratic formula, if the directions say anything about rounding or writing in simplest radical form. Completing the square is usually the least preferred method, I would say, overall, but the directions will say solve by completing the square, or it might have an even x term, so some of you might really like that. If they ask you to write something in vertex form first, that would be another reason to use completing the square. So a little note here, we want to always set the quadratic equal to 0 at the beginning unless we're going to use inverse operations. So we're going to keep that in mind because, as you recall, inverse operations, we always move the number over to the other side of the equal sign so we can take square roots. Okay, let's look at number 1. So solve this quadratic equation. Well, already, looking at my directions, there is not a lot of fancy stuff going on here. Doesn't tell me to round, doesn't tell me simplest radical form. So right away, I am thinking that this is going to be factoring. It's the most easy and straightforward. We're not going to solve this, but let's kind of go through what we would do to start solving it. The thing that I don't like is that it's not set equal to 0, but I do have a positive x squared term over here on the left-hand side. So those of you thinking that I should be moving my terms from the right side over to the left side, you are correct. Some of you do it by sorting. Some of you prefer to do it by inverse operation. Obviously, we're breaking free from this equal sign. So if I do this, I end up with x squared minus 3x minus 10 is equal to 0. And from here on out, we would set up the box and we would be able to find two nice integer zeros, root solutions. Okay, so this is factoring because of the directions. What do we want to say? The directions don't say anything. They just say, directions say solve for x. Oops. Solve for x and nothing more. Okay. Number 2, we have another problem here. Okay. So this one says find the zeros algebraically. Okay. Write your answer in simplest radical form. Okay, because of this, right away, factoring is not going to be our friend. Okay, so now we want to look at the structure of this. Okay, does this look like something like number 1, or do we have any nice form? To me, it looks like this chunk squared equaling a number. I know that chunk is not an official math word. Please don't write that on any tests, but we'll talk about the reasoning in just a moment. To me, this is going to be an inverse operation because we can take the square roots. Okay, there's a couple reasons why I'm picking inverse operations. First, it said simplest radical form. So simplest radical form, I'm just going to abbreviate. And then also, it takes the form of this all squared equaling a number. Okay, so those are two main reasons why I would use inverse operations, aka square roots, to help me solve this one. Okay, this should be question, oh, I don't know why that says question 5. All right, question number 3. Find the roots algebraically, round your answer to the nearest hundredth. Okay, guys, you are picking up what I'm putting down, I'm hoping, and realizing that when it says anything about this, factoring is out. It doesn't look to me like we can use square roots because I don't see that nice form that we saw in number 2. So let's first get this set equal to 0. And it looks like our x squared term is positive on the left. So we're just going to move all of our other terms over to the right-hand side. If it switches sides, it switches signs. So 2x squared minus 9x plus 3 equals, now we don't have anything over on this side, equals 0. Well, if it said to complete the square, I'd probably complete the square, but look at that. It's not easy to take half of 9. We end up with a lot of decimals. That's pretty gross. At this point, because we have to do some rounding, I think we want to use a quadratic formula. Because why? Well, the directions say round. And then also that b term, it's an odd number. And it's not easy to take half of that to do completing the square. Inverse operations is totally out because it doesn't take that form. Okay, this should be question number 4. It says solve for x algebraically by completing the square. Oh my gosh, like, hello. We're going to complete the square here because it literally tells us to do that, okay? And then also the directions are going to say simplest radical form. So there's a couple of reasons why, because the directions say so. So the directions say so. And then also we have that simplest radical form. So factoring is out when that happens. But simplest radical form tells me that we're going to use a method other than factoring. Okay, let's just get this set up just to get a little bit of practice for completing the square. So x squared plus 4x, and we move the 1 over off to the side, or some people bring it over to the other side of the equal sign at this point. I'm going to wait to do that. We want to find 2 numbers that add to 4 that are the same to complete this square. So if you're thinking x plus 2, all times x plus 2, you are right, because 2 plus 2 is 4. Yay. So 2 times 2 is also 4. That's great how that works. 2 times 2 is 4. So if we're adding 4, we also have to subtract 4. So the 1 minus 4 becomes minus 3, and that would equal 0. And then at this point, we would move the 3 over to the other side and write this as x plus 2 all squared is equal to 3. And aha, this is kind of like a combination of inverse operations, but we obviously start off by completing the square when it tells us. So let's make sure that we check that off. So in the practice, you are going to be actually picking the method and solving with it, but hopefully this was a nice way to show you what methods we should pick.